Welcome friends to my channel Civil Engineering Services. This is Ripon with you. In this tutorial we will be able to know about design of R.C.C tied column which shaped bearing capacity will be 90 ton axial loaded. There are three methods to design of R.C.C tied column. In this tutorial we have followed the design method steel ratio fixed method. Steel ratio fixed method. Column length is not shown, so reduction factor R should not be calculated. If the length of the column is considered, then reduction factor should be calculated. In this tutorial we have not considered the column length, so it is not needed to calculate reduction factor. Then given data, axial load P equal to 90 ton, which bearing capacity will be 90 ton, 90,000 kg. Ultimate compressive stress of concrete A prime C equal to 200 kg per square centimeter. The ultimate compressive stress of the concrete A prime C equal to 200 kg per square centimeter. Allowable tensile stress of steel Fs equal to 1600 kg per square centimeter. This is the allowable tensile stress of steel. And the yield strength of steel Fy equal to 4000 kg per square centimeter. This information is given. Let's to find out the others information. In this tutorial I have told you again before the design method we have followed steel ratio fixed method. So let the steel ratio rho g equal to 0.02. Known that shaped bearing capacity of tight column P equal to 0.85 Ag bracket 0.25 A prime C plus Fs rho g. This is the formula of R.C.C column design. In this formula P equal to the amount of axial load, Ag equal to stands for the cross sectional area of R.C.C column, and 0.85 is stand for load factor between circular column and R.C.C tight column. This 0.85 is stand for load factor for R.C.C tight column. A prime C, the ultimate compressive stress of concrete, plus Fs. Fs stands for allowable tensile stress of steel, and rho g stands for the steel ratio, close bracket. P, the value for P is 90,000 kg. 90,000 equal to 0.85 Ag 0.25 A prime C. The value for A prime C is 200 kg per square centimeter plus Fs. The value for plus Fs value, the value for Fs value 1600 kg per square centimeter. Multiplication, the value for rho g, steel ratio 0.02, multiplication 0.02 equal to 90,000 equal to 0.85 Ag. After multiplying 0.25 and 200, into 200 equal to 50, and 1600 into 0.02 equal to 32.85 Ag equal to 90,000 divided 82. After additioning 50 plus 32 equal to 82. 0.85 Ag equal to, after dividing 90,000 with 82, we can get 90,000 divide 82, we can get 1097.5609. So 1097.561. Okay, Ag equal to 1097.561 divide 0.85. This 0.85 1097.561 divide 0.85, we can get 1291.25. 1291.25. This value for Ag. Ag stands for cross-sectional area of R.C.C column. Then we can say this value is for cross-sectional area of the column. Ag cross-sectional area of column 1291.25 square centimeter. Then column size, after making root over, we can get 35.934 centimeter into 35.934 centimeter. Making root over, we can get 35.93 centimeter. Then we can consider the column size 36 centimeter into 36 centimeter square size. Then the cross sectional area of the column, we can get 36 centimeter into 36 centimeter, 1296 square centimeter, which is greater than 1291.25 square centimeter. Then this is saved value. Okay, this value is saved. Okay, quantity of longitudinal bar, that means main bar. Area of steel equal to rho g into AG. AST means area of steel, cross sectional area of steel, rho g steel ratio, and AG the cross sectional area of column. The value of rho g 0.02 multiplication the value of AG 1296 square centimeter equal to 25.92 square centimeter. Okay, this is the area of steel main bar, cross sectional area of steel 25.92 square centimeter. Let the diameter of main bar 22 mm dia. Then numbers of bar, we can get total area 25.92 square centimeter, and the area for a 22 mm dia rebar pi by 4 into 2.2 whole square. This is for a cross sectional area of a bar, 22 mm dia bar cross sectional area. Total steel area this 25.92, and one piece area 5 by 4 into 2.2 square centimeter. Then we need 6.81 piece. Then we can say 8 piece, total 8 piece. Okay, design of tie bar. Let the diameter of the tie bar 8 mm dia. Then the rules of the design of tie bar. First time, the diameter of main bar into multiplication 16. The spacing of tie bar should be the diameter of main bar multiplication 16. Then the main bar diameter is 2.2 centimeter into 16 equal to 32.2 centimeter. The diameter of and others rules, the diameter of tie bar multiplication 48. The diameter of tie bar is 0.8 centimeter, 8 mm, that is 0.8 centimeter, multiplication 48 equal to 38.4 centimeter. And the others rule should be minimum side dimension of the column, cross section of column. Minimum side dimension, minimum one side dimension. Then we can get the side dimension of the column is 36 centimeter by 36 centimeter. Okay, then 8 mm dia tie bar should be set 32 centimeter center to center. Okay, the tie bar 8 mm dia should be set 32 centimeter center to center. This should be less distance 32 centimeter, 38, 36 in between. From this 3 dimension we can say this is the smallest, so the spacing should be 32 centimeter center to center tie bar. Okay, then the design of the column 36 centimeter by 36 centimeter, and the longitudinal bar is 8 piece 22 mm dia main bar, and the stirrup tie bar should be 8 mm dia tie bar at the rate 32 centimeter center to center each row. For the sake of each row 32 centimeter center to center. Okay, thank you.